All right, there's one other kind of problem that you're going to see in Chapter 19, and that deals with what's called the margin of error. So here's our formula for confidence intervals. Remember, standard error could be replaced with the actual formula. So I could write it p hat plus or minus v star times, that's the p hat q hat over n. Margin of error refers to the piece we add and subtract. So the piece we add and subtract. That's the margin of error. So suppose you want to take a poll, so that's a survey, and estimate voter support within 3%. So this means we only want to go up and down 3%, but we want to keep a 95% confidence. How big should our sample be? That means we're looking for n. Well, within 3%, this is identifying how big we want the margin of error to be, how far the up and the down should go. So I can actually set up an equation. The margin of error is the same as saying my v star times my square root p hat q hat over n. That's just a sentence in English. Margin of error is this chunk of the formula. So now I can fill in some pieces from the story problem. I want the margin of error to be only 3%, so that's 0.03. Let's see, z star for a 95% confidence is 1.96. I actually have this one memorized because it's used so often, but you can always go back and do your little sketch and calculate your z star. And then in this one, let's see, n is what I'm solving for. It's a sample size, so I'm going to leave that as a variable. I need a p hat and a q hat, but that wasn't mentioned anywhere in the story problem. So if there's no idea, use 0.5. It would be the most conservative guess. So if there's no information, use p hat equals 0.5. Now there might be a situation where it says last year voter support was 0.87, was 87%. Then we'd go ahead and use 0.87 in our story problem. Okay, so use anything they give you in the story problem, but if there's nothing, you can use 0.5. All right, so now we just have some algebra to do. All right, so let's see if I can simplify this a little bit. Square root of a fraction, so I can just do the square root of the top divided by the square root of the bottom. These two things are being multiplied, so I can just put that all over one fraction. Okay. I can still simplify that top piece a little bit. 0.5 times 0.5 is 0.25. So I could go ahead and multiply 1.96 times the square root of 0.25. So that's 0.03, and that's going to leave me with 0.98 over the square root of n. Well, in order to solve, I need the variable alone. That doesn't work if it's on the bottom, so I'm going to multiply both sides by the square root of n. Square root of n times 0.03 is just 0.03 times the square root of n. We usually put variables in the back. Top and bottom give us nothing there, excuse me, 1. And again, I'm still looking for that square root of n to be alone, so I'll divide both sides by 0.03. So I get that the square root of n is equal to 32.67. I rounded that just a little bit. And to get n alone, I would square to undo that square root. So I get n is approximately 1067.11. Now the question was about a sample size, so this represents a number of people I need to ask. I cannot ask 0.11 of a person, so we're going to need to round this. Because we're looking for the smallest number that would give us these criteria, we will always round up. Always. You're like, but 0.11, that's so small. No, always round up. So the sample size we need is 1,068 people. And that's that story problem.